Let's look at solving this rational equation. This is problem 52 from the Chapter 6 review section. In order to find the right multiplier, because I can't cross multiply here because this is not a proportion. So I'll have to find the correct multiplier that when I multiply through, it will cancel all of the denominators that we have in our fractions. So in order to determine what that correct multiplier would be, we need to first of all make sure that the denominators are all in factored form. Well, x plus 1 cannot be factored any further, neither can x plus 2, but that trinomial hopefully is factorable. And it actually factors into the product of those two binomials. So if I wanted to cancel this denominator, I would have to multiply this fraction by that pair of binomials. So then the x plus 1s would cancel, the x plus 2s would cancel, and of course this trinomial was equivalent to those two binomials, so it's gone. And all I would have left on this side of the equation would be 4x plus 1. But of course, if I multiply that side of the equation by that pair of binomials, I have to multiply these two terms by that same pair of binomials. I can't pick to multiply one side of the equation by one thing and not do that same thing to the other side of the equation. So when I multiply these two terms by that same pair of binomials, here the x plus 1 binomials will cancel, leaving me x plus 2 to be multiplied times x plus 5. Here the x plus 2's will cancel, leaving me minus x to be multiplied times the binomial x plus 1. And we now have an equation free of fractions that we can solve. This is going to require us to use FOIL to multiply these binomials. So that's going to give us x squared plus 5x plus 2x more, so that's plus 7x, plus 10, minus x squared minus 1x equals 4x plus 1. If I combine the like terms here, x squared minus x squared, that disappears into 0. 7x minus 1x is 6x. And I have a nice linear equation that I can solve. So I'll subtract 4x from both sides, subtract 10 from both sides, and dividing by 2, we get our solution that x equals negative 9/2. Is that one of our restrictions on x that come from the variable being in the denominator? No. The restriction here would be negative 1, wouldn't it? Because negative 1 plus 1 would make that denominator 0. The restriction from here would be negative 2. And likewise, those would be the restrictions here, since that polynomial is equal to those two binomials when we factor. So our solution is not one of the restrictions. We would have to plug it in to see if it really worked. And frankly, I don't think we want to do that, at least not in this video.